In the next few videos, we'll be exploring a classic computer science problem. The problem involves sorting a list of objects from smallest to largest. As you'll soon see, there are many different ways to do this. In this lecture, you're going to learn about the bubble sort algorithm. To learn about bubble sort, we'll start with an example. Here is the first list that we'll sort. It has the values 7, 3, 5, and 2. And we're going to follow the bubble sort algorithm to sort it. We're going to start at index 0, which I'm going to label with I, and work towards the end of the list, which I'm going to label with E. We'll start by bubbling the largest item in the list into the rightmost position. We do that by comparing the item at index I, the 7, with the item at index I plus 1. Because 7 is greater than 3, we'll swap these. Now the 3 is at index 0, and the 7 is at index 1. The rest of the list is unchanged. E still labels the last position. We move the I to above index 1, because we're about to compare the item at index 1 with the item at index 2. We compare the item at index I with the item at index I plus 1. 7 is larger than 5, so those items are swapped as well. The I is now above the item at index 2, and the E, again, is still over the last item of the list. The item at index I, the 7, is compared with the item at I plus 1, the 2, and those items are swapped. We've now completed one pass of the bubble sort algorithm, and the largest item in the list, the 7, is in its correct sorted position. We'll start the second pass of the algorithm. This time, the end is the second last item of the list. The last item is already sorted. And we still start at the beginning, so we'll label that with I. We use this line to distinguish the unsorted part from the sorted part. Like before, we compare the item at index I with the one at I plus 1, and we swap if necessary. In this case, we don't need to swap the 5 and the 3. Next, the 5 is compared with the 2, and they are swapped. We've reached the end of the second pass, and the 5 is now moved into its correct sorted position, the second last position in the list. There's one more pass to do. The sorted part of the list now has 2 items in it. I begins at index 0, and this time the end is at index 1, the last item in the unsorted part of the list. The item at index I is compared with the 1 at I plus 1, and the 3 and 2 are swapped. The third pass to the algorithm is complete, and the list is now sorted. Now that we've seen a specific example, we'll draw a few pictures of the state of the list in general as the algorithm progresses. At the beginning, the entire list is unsorted. After some number of passes have been completed, part of the list is unsorted and part is sorted. The unsorted part goes from index 0 to index end. End of the algorithm, the index end is at index 0, and all of the items of the list are sorted. To be precise, the item at index 0 is technically unsorted, but we know that it's smaller than the rest because it's been compared to the others. Now let's implement the algorithm. We'll keep track of the index of the last unsorted item of the list. Initially, end will refer to the index of the last item in the list, because the entire list is unsorted. We know that we need to make several passes through this algorithm, and in our implementation we'll do that with a while loop. We stop when end is equal to 0, so we continue as long as it isn't. In each pass, we bubble once through the unsorted section of the list to move the largest item to index end. At that point, the sorted section of the list has grown by 1, so we decrease the index end by 1. Starting at index 0 of the sorted section, we compare the element at index I with the one at index I plus 1, If it's larger than it, we swap the items. Notice that we're using a new notation. The list at index I is assigned the item of the list originally at I plus 1, and the list at I plus 1 is assigned the item originally at index I. Also notice the for loop header. The unsorted part of the list goes from index 0 to index end, but the value of I, the largest value of I, is end minus 1. That's because in the body of the loop, end minus 1 would be compared to the item 1 greater than it, the item at index end. Finally, let's run the doc test. The test case passed, so there's no output in the shell.